Okay, so in this video, we're going to keep working on the layout of the SRAM cell. I'm just going to start to push everything a little bit closer together. I'm not going to try and really minimize the area of the SRAM. I'm just going to work on getting everything connected so we can see what the cell might look like. Later on, I'll show you a method to compact it even further. Now, one of the things you'll notice with the SRAM cell is that it has these green lines. These are dummy poly lines that are placed in the layout, and they help with matching and to mitigate different layout effects of the transistors. We're going to leave these on for now, but one of the things that you can do if you want to get rid of them is you can go to the cell and go to Edit, Hierarchy, Flatten, and you can select Flatten P cells, click OK, and that would flatten the cell so that you could delete different objects from it. I'm going to undo this because I want the cell to stay intact. So I'm going to do a bit of rearranging. I'm going to pause here and you'll see what it looks like after I do that rearranging. All right, so one of the things that you can see now is that I've minimized the cell area. I have brought everything to where all of the diffusions make contact with one another, and that's probably going to be about as compact as I can get it. Now, if I look at a few of these diffusions, for instance, the P diffusion right here, you can see that it doesn't make a perfect rectangle. I'm going to add a rectangle around this just by pressing R. And drawing it, and then I'm going to use S to stretch the rectangle. All right, so now we have a perfect rectangle for the PP diffusion. We'll look at the NP diffusions, and we can see, again, we don't quite have a perfect rectangle, so I'm going to add a rectangle. All right, and now we have a nice rectangle for the NP diffusions, and then let's check the N well. We probably want a perfect rectangle for the N well as well. All right, I'm going to turn all the layers back on. I'm going to turn those dummy polys off just because they make it a little bit distracting. And now we have everything set up to where we can connect things. Now we have these two transistors that I'm circling. These are our bottom inverter. So this would be these two transistors. These form an inverter, and the top ones form another inverter. So I'm going to make some connections to create that inverter. Okay, so I've been adding some features here. So you can see one thing I've done is I've added a piece of metal that's connecting the two drains of the PMOS and NMOS device. Now I'm going to tie the supply side of the transistors to VDD. To do that, I need to make a wire, and we're going to do this on the M2 layer. So I'm going to add a via by typing O. I'm going to make the via from M1 to M2. I'm going to orient the metal M1 vertically, and I'm going to put this right in the center line. I'm going to come and do the same thing over here. And now I'm going to press P for a path. I'm going to connect to VDD. And now I'm going to add VDD metal. So these cells are going to be designed so that they can join up with each other by mirroring them along the y-axis. And so I'm making the metal long enough so that it is continuous if it's mirrored. All right, so now we have the VDD connection. We have the inverter connected. So we just need to go work on the connections to the gate, the read transistors, and the connections to the bit lines, and then the connections to ground. Okay, for ground, I'm going to add another via. I'm going to add that via in this direction. I'm going to come up here and I'm just going to copy this metal by pressing C. I'm going to move that metal down here. So now I have a ground connection. I need another ground connection for the top transistor right here. I'm going to do the same thing. I'm just going to come back and copy this metal. All right, so we're almost done. We just need to now connect the word line here and the bit lines here and here. So the word line is going to be tied to this, to this gate right here. So what I'm going to do is I'm going to type O, and I'm going to make an M1 to PO connection. So this is an M1 to poly. Probably going to have to extend the well just a little bit in order to pass the DRC, but I'm going to put it right about here. And now I'm going to add an M1 to M2. This is going to cause the metal to be a little bit too close. I might need to move this just a little bit. Okay, now I've gone ahead and connected M1 to M2 and M2 to M3, and now I'm going to route from M3 up through the structure. So I'm going to type P. So now we've got our word line. The last thing I need to do now is to connect the bit lines. Again, I'm going to add a via from M1 to M2. Put this on M2. And I'm going to copy it. Okay, so now our SRAM is more or less completely routed, and we're going to have to run some checks on the SRAM, but I need to also move the pins into the proper location. First thing I'm going to, now that I have an outline for the cell, I'm going to go ahead and move everything so that it lines up and is oriented to 0, 0. And let's move our pins into place. So this first pin is W, so this is going to go on the word line. I need to move it to the right layer. This would be M3 pin. Here's our ground pin. This will be an M2 pin. And I need a copy of this one because the ground line is separated in this layout. I need a bit line pin. Okay, we're going to move the bit line pin to M2 pin. Also go ahead and stretch it. So Control D, and then I hit S, and we can stretch. The bit bar. This is an M2 pin, so that's fine. And VDD. All right, so there's our basic SRAM cell. Now we're probably going to have to clean up a few DRC errors, but this layout is functional. Everything is connected, and so we're going to run DRC and LVS just to do the comparisons, and we'll do that in the next video.